Hey everyone, Mr. Hauk here. In today's video, we're going to be solving systems of equations that involve both linear and quadratic equations. Let's go ahead and get started. So in Algebra 1, you learned how to solve strictly linear systems of two equations, both algebraically with substitution and elimination, and graphically as well. Let's review this process before we begin exploring solving systems, including both linear and quadratic equations. So let's consider elimination first. When solving a linear system by elimination, the goal was to eliminate one of the two variables, either x or y, and we would do that by multiplying one or both of the equations by some number to force the elimination to happen. So notice, if I take the top equation, and if I multiply the top equation by 4, well, let's see what ends up happening. So the top equation, let's multiply all terms in the top by 4. So 4 times 2x is 8x, 4 times y is 4y, and 4 times negative 7 is negative 28. The bottom equation, let's leave it alone. We would get x minus 4y equals negative 8. So by multiplying the entire top equation by 4, notice it turned the y into a 4y. And this is going to allow us to eliminate the y variable entirely, because by adding the equations together, 4y and negative 4y will cancel. So let's go ahead and add these equations. 8x plus x is going to give us 9x. Obviously, we can see the whole point of this was to eliminate the y variables. And 9x equals, let's see, negative 28 minus 8, that's going to be negative 36. And then by dividing both sides by 9, we get that x equals negative 4. All right, pretty simple. In order to solve for y, we're now going to pick one of the two equations. Usually you'd want to pick the easier equation. We're going to plug in x equals negative 4 and solve for y. I'm going to go ahead and pick the bottom equation, x minus 4y equals negative 8. So now let's see, x minus 4y equals negative 8. Let's go ahead and substitute the x with negative 4. So negative 4 minus 4y equals negative 8. And then let's just solve for y. So this is negative 4 minus 4y equals negative 8. Let's go ahead and add 4 to both sides. So we get negative 4y equals negative 4. And then we can see by dividing both sides by negative 4, we get y equals positive 1. And then we're done. We've solved the system because we found the x-coordinate, found the y-coordinate. So the solution is the point negative 4, 1. X going first, obviously, y going second. Okay, so that's how we would solve a linear system by elimination. Let's take the exact same system. Let's now solve it by substitution. Notice it's the exact same system, so for our answer, we better end up getting negative 4, 1. If we don't, we definitely made a mistake somewhere. But here's the idea for substitution. When solving a system by substitution, first you're going to look at either equation, and you're going to solve one of those two equations for a single variable. What I'm going to end up doing is I'm actually going to take the top equation, 2x plus y equals negative 7, and I'm going to solve it for y. So 2x plus y, let me get green here. So 2x plus y equals negative 7. If I solve it for y, that means I'd be subtracting 2x on both sides and getting y by itself. So I'd get y equals negative 2x minus 7. The next step is once we have solved one of the two equations, we want to substitute y into the other equation. So we didn't solve for x minus 4y equals negative 8. So we're going to take y equals negative 2x minus 7. And in this y, we're going to substitute negative 2x minus 7. So we'll have x minus 4y equals negative 8. This is going to give us x minus 4. Here we're going to replace the y, so this y right here, with negative 2x minus 7. So negative 4 times negative 2x minus 7 equals negative 8. Let's distribute the negative 4, so we get x plus 8x plus 28 equals negative 8. And let's just solve for x. X plus 8x, this is 9x. Go ahead and subtract the 28 over, so negative 8 minus 28, that's negative 36. And once again, we can see after dividing both sides by 9, we get x equals negative 4. Then we'll go ahead and plug in negative 4 into one of the two equations. I'm going to choose y equals negative 2x minus 7. Notice the reason I'm doing that is we've already isolated for y. And if I just plug in x equals negative 4 to right there, well, it's going to really quickly and easily solve for y for me. So we have y equals negative 2x minus 7. This will give us y equals negative 2 times negative 4 minus 7. And negative 2 times negative 4 is 8. 8 minus 7 tells me y equals positive 1. And we can once again see the solution, just like in the previous example, is negative 4, positive 1. Just like it was supposed to be. Like I said, if you end up getting something different there, it definitely means you goofed up somewhere because it's the exact same system. So the last thing we're going to do is we're going to look at solving a system of linear equations graphically. And what we're looking for is to graph both of these equations and look for their point of intersection. This will give us the solution to the system. And what I'm going to do is I'm going to go ahead and rewrite both of these equations in slope-intercept form, which is y equals mx plus b, so that they're very easy to graph. So the first equation, 2x plus y equals negative 7. This is pretty quick and easy to get into slope-intercept form. I'm just going to subtract 2x on both sides. So we get y equals negative 2x minus 7. The second equation, x minus 4y equals negative 8. Couple extra steps. Let's go ahead and subtract x on both sides. So we get negative 4y equals negative x minus 8. And then let's go ahead and divide everything by negative 4. And that's going to end up giving us y equals 1/4 x plus 2. So these are the two equations that we're going to use because they're the slope-intercept form equations and they're very, very easy to graph. So starting with y equals negative 2x minus 7, remember back from Algebra 1, y equals mx plus b, m is the slope, tells you how to move, b is the y-intercept, tells you basically where to start. So I'm going to be starting at negative 7 on the y-axis. Let's put a point there. And with the slope being negative 2, that's negative 2 over 1, well, remember, slope is rise over run. So what this is telling you to do is go down 2, right 1. Now, I can't go down 2, so instead of going down 2, right 1, I can do the exact opposite and go up 2, left 1, because that's actually the same direction. So from that negative 7, let's go up 2, left 1, up 2, left 1, and we'll repeat this process as many times as possible. And now we have a collection of points. Let's go ahead and connect them with a straight line. And this was the equation y equals negative 2x minus 7. Let's do the same thing for our other linear equation. So y equals 1/4 x plus 2. Again, y-intercept is 2. That's where we're going to start on the y-axis. The slope here is 1 over 4. This is telling us either go up 1, right 4, or the exact opposite, down 1, left 4. So up 1, right 4 from that point 2, up 1, right 4, or alternatively, to keep the pattern going in the other direction, down 1, left 4, down 1, left 4. And then we'll go ahead and connect the points with a line. The intersection of the two lines is going to be the solution to the system. Notice the 2 points are intersecting right here at negative 4, positive 1. And once again, this should not have been a surprise to anybody because this is the exact same system all the way throughout. And every single time, our solution was negative 4, positive 1. This was completely intentional so that you can see that no matter how you decide to solve a system, you always get to the correct answer. So the purpose really of today's video is to show us how we can solve systems involving both a linear and a quadratic equation, rather than strictly just two linear equations. So let's look at some examples, starting with substitution. So we want to solve the system below algebraically using substitution. We're also going to want to check our solution by plugging it back into the system to make sure that it works. So here's the strategy here. Substitution, even though we now have a quadratic equation, is going to work pretty much the same. Notice that both of these equations have already been solved for y. So we know that y equals x squared minus 2x plus 4. We also know that y equals 2x plus 1. So what I'm going to do is I'm going to replace the y in the second equation with x squared minus 2x plus 4. And this is what we would end up getting. So we get, replacing this y with x squared minus 2x plus 4. So we're going to get x squared minus 2x plus 4 equals 2x plus 1. Once we've done that, we want to get the right side equal to 0. So basically we're trying to set it up so that we can solve the quadratic. So to get the right side equal to 0, we're going to need to subtract 2x from both sides, and we're going to need to subtract 1 from both sides. This is going to give us x squared minus 4x plus 3 equals 0. All right, so the next step is to solve the quadratic. You can use any method of your choice. Factoring is what I'm going to use. It's the easier method in my opinion for this problem. You could use quadratic formula to solve the quadratic if you're comfortable with the quadratic formula. And there's other methods for solving quadratics as well. So, but I'm going to choose factoring. So for this, x squared minus 4x plus 3 equals 0. Let's think about, we want to find two numbers that multiply to 3, but those same two numbers have to add to negative 4. So I'm thinking negative 3 and negative 1, because negative 3 times negative 1 will give me a positive 3, but negative 3 plus negative 1 will give me a negative 4. And when we solve for a quadratic, we're going to use something called the zero product property, because we have something times something else equals 0. And the only way that you can multiply two things together and get a 0 is if one or both of those factors were 0 itself. So that means that we can say x minus 3 equals 0, because x minus 3 is one of the factors. And we can also say that x minus 1 equals 0, because x minus 1 is the other factor. And these are both very simple to solve. X minus 3 equals 0. Well, after adding 3 to both sides, you get x equals 3. X minus 1 equals 0. After adding 1 to both sides, we get that x equals 1. So what this did is it found both of our x coordinates for us, but we still need to find the y coordinates. So what we're going to do is we're going to plug x equals 3 and x equals 1 into the easier equation, which, by the way, the easier equation is pretty much always going to be the linear equation in most cases. We're going to plug both those x's into the easier equation to find the y values. So let's go ahead and do that. I'm going to start with x equals 3. So for x equals 3, let's look at our equations here. The easier equation to plug into is definitely going to be the linear equation, y equals 2x plus 1. So y equals 2x plus 1. Let's plug in 3 for the x value. So y equals 2 times 3 plus 1, which tells us that y equals 7. Now let's do the same thing, but for x equals 1. Same deal, plug into the easier equation, y equals 2x plus 1. This time we're plugging 1 in for x, so this is y equals 2 times 1 plus 1. And this is going to tell us 2 times 1 is 2, 2 plus 1 is 3, so y equals 3. And this gave us the solutions to the system. Notice there are two solutions here. When x is 3, y is 7, So let's write that down as one of our solutions. So solutions, when x is 3, y is 7, and when x is 1, y is 3. So our two solutions are 3, 7, and 1, 3. Now, one of the really nice things about systems of equations is when you find solutions to the system, you can actually check your work. What we would do is we take these two solutions and individually we check them both with the entire system. If they check out, which it'll be pretty easy to see if they check out, then those solutions actually work. So let's check them one at a time. Let's start with 3, 7. This is our first solution here. So what we're going to do is we're going to plug in 3 for x and 7 for y into the system. So looking at the top equation here, y equals x squared minus 2x plus 4. Let's plug in 7 for the y. So 7 equals, let's plug in 3 for both the x's. So 3 squared minus 2 times 3 plus 4. And let's do some quick math here. 3 squared is 9. Minus 2 times 3, that's minus 6. 9 minus 6 is 3. 3 plus 4 is 7. So you get 7 equals 7. That's a true statement. Everything checks out. Now let's plug in 3, 7 into the second equation, y equals 2x plus 1. So we're going to plug in 7 for y, 2 times, and then 3 for x, plus 1. And then once again, 2 times 3 is 6. 6 plus 1 is 7. We get 7 equals 7, which once again checks out. So we can see that the solution 3, 7 is definitely a correct solution. Now let's check the coordinate or the solution 1, 3. So same strategy. Let's plug in 1, 3 into both equations and see if it works. So for y equals x squared minus 2x plus 4, we're going to plug in 3 for y equals x squared, so that's going to be 1 squared minus 2x, so minus 2 times 1 plus 4. 1 squared is 1, minus 2, then plus 4. Well, 1 minus 2 is negative 1. Negative 1 plus 4 is positive 3. So we do in fact get that 3 equals 3, and everything checks out. Now let's plug it into the second equation, y equals 2x minus 1. So we plug in 3 for y, 2 times x, so that's 2 times 1, and then plus 1. And this one's pretty easy. 2 plus 1, that's going to give us 3. So 3 equals 3. And again, everything checks out. So that was solving a system with a linear and a quadratic equation by substitution. Now let's do the same thing. It's going to be a different system, but let's solve a system now. Instead of using substitution, let's use elimination, the other algebraic method for systems. And once again, we're going to check our solution by plugging it back into the system. All right, so the first thing that we're going to want to do when solving a system by elimination is we're going to want to rearrange the equation and line up all the terms. So here's what I mean. Notice that, our top equation is y equals x squared plus 5x plus 9. The second equation, negative x plus y equals 21, the pieces are not lined up with each other. I want to line the equal signs up, I want to line the y's up, I want to line the x's up. So I'm going to line it up similar to the top equation. And in my mind, one of the goals that I have is I actually want to eliminate the y's. The reason I want to eliminate the y's is because it's going to leave the equation in terms of x. Notice x is the squared variable. If I can get all the x's grouped up and the y's eliminated, then it's going to give me a quadratic equation that I can actually solve for. So I'm going to take the bottom equation, negative x plus y equals 21, and I'm going to rearrange it so that it's in the same format as the top equation. So here's what that would look like. The top equation, or the system in general, well, the top equation is going to stay the same. Y equals x squared plus 5x plus 9. I want only y to be on the left for the second equation. So I'm going to take the negative x, I'm going to add it to the other side. So this is going to leave me as y equals positive x plus 21. So notice this is the same equation, but I've taken it and I've rearranged it so that y has been isolated. Also notice that I've lined up all the terms so that I can go ahead and add all the terms together at some point eventually here. So now let's go through with the elimination steps. When we're solving by elimination, we want to get variables to eliminate. And in this case, we want the y's to eliminate, so that again, once the y's are gone, and we'll get a 0 on this side, we can collect the x terms, and that's going to give us a quadratic equation that we can then solve. So we're going to multiply one or both equations to force the elimination of a variable. Again, in this case, that's going to be y, and then we're going to want to add the equations together. So let's think about how we're going to multiply this. So let's rewrite our system. Y equals x squared plus 5x plus 9. And then y equals x plus 21. Well, if we want the y's to eliminate each other, let's just multiply the bottom equation times -1. So let's do that. Bottom equation, multiply it times -1, and this is going to give us our new system. Well, the top equation isn't getting messed with, so it's still y equals x squared plus 5x plus 9. The bottom equation is now going to become -y, because y is getting multiplied by -1, equals -x minus 21. So all the terms here got multiplied by -1. And then we can go ahead and add the equations together. So we can see y and -y will cancel each other out. X squared has nothing to add to, so it's just going to drop down. 5x plus -x is going to be 4x. And 9 plus -21 right here is going to be -12. And by the way, the y's that canceled, that makes the left side here equal to 0. So now that we have a quadratic equal to 0, we can solve this quadratic. Again, either using factoring or quadratic formula if you want to. Once again, this is going to be a pretty easy equation to factor, so I'm going to take the factoring route. So we have 0 equals x squared plus 4x minus 12. Let's go ahead and factor this. Again, we want to think two numbers to multiply to -12, but those same two numbers have to add to +4. So that's going to be 6 and -2. 6 times -2 is -12. 6 plus -2 is +4. And then let's go ahead and solve those. So using the zero product property, x plus 6 equals 0. X minus 2 equals 0. This is going to tell us that x equals -6. And this will tell us that x equals +2. Notice that once you've gotten past the second step, this is the exact same process as substitution. We were able to solve the quadratic. Once we found these x values, we're going to plug them back in to the easier equation, which is going to be the linear equation right there, y equals x plus 21, to find the y values. So that's the last step here. Plug into the easier equation to solve for y. So let's do x equals 6 first. So for x equals, -6, for x equals -6, again, the easier equation is going to be y equals x plus 21. So y equals x plus 21. Let's plug in -6 for x. That gives us y equals -6 plus 21, which tells us that y equals 15. Ooh, that was terrible. Let's try that again. Oh, even worse. I'm going to get this, I promise. I don't know why, but there we go. Much better. Okay, now let's look at for x equals 2. All right, so again, easier equation, y equals x plus 21. Plug in 2 for x. That gives us y equals 2 plus 21, which tells us that y equals 23. And there's our two solutions to the system. So we can see here, if x is -6, y is 15, so -6, 15 is the solution. And we can also see that when x is 2, y equals 23. And then again, let's go ahead and check these solutions. For the rest of the notes after this problem, we're not going to bother with checking every solution, but let's go ahead and check this one as well. So let's go ahead and check negative 615 first. Plugging it into the first equation, the y value is going to be 15 equals, so x squared, that's going to be negative 6 squared, plus 5x, that's going to be 5 times negative 6, plus 9. Doing some quick math here, negative 6 squared is 36. 5 times negative 6 is minus 30. 36 minus 30 is 6, and then 6 plus 9 will give us 15. So we can see that 15 equals 15. Everything checks out. It's a solution to the first equation. Now let's check negative 615 with the second equation. We have negative x plus y equals 21. So negative x, that's going to be negative 6, plus y, that's going to be 15, equals 21. Let's look at the left side here. Negative 6, that's positive 6. 6 plus 15 is in fact 21. So 21 equals 21, and that checks out. So negative 6 and 15 is definitely a solution to the system. Now let's check 223. So same deal, top equation, y equals x squared plus 5x plus 9. Plug in 23 for y, so 23 equals x squared, so that'll be 2 squared, plus 5x, so 5 times 2, then plus 9. Do some quick math here. 2 squared is 4, 5 times 2 is 10, 4 plus 10 is 14, and 14 plus 9 is 23. So 23 does in fact equal 23. That checks out. And then lastly, let's plug into the linear equation, the second equation, negative x plus y equals 21. So that's negative 2 for x plus 23 for y equals 21. Well, negative 2 plus 23 is 21. 21 equals 21, and it's an easy check. Okay, so those are quick and easy ways to check if your solution is correct or not. So last thing we want to talk about are the types of solutions we can have for these kinds of systems. So if we have a system where one equation is quadratic and one equation is linear, then you actually have 3 different types of solutions. You can run into scenarios where we have 2 solutions, meaning that the parabola from the quadratic and the line from the linear function, they intersect in 2 different places, meaning that you have 2 solutions. That's what the last 2 example problems on the previous page, those were examples of 2 solution systems. But you can also have systems that only have 1 solution, meaning that the line crosses the parabola in exactly 1 place. That'd be an example of a 1 solution system. And then you can also have a system where there are no solutions, meaning that the line never intersects with the parabola. So that'd be an example of no real solution. So let's see a couple examples here. In this example, we're going to want to solve the system algebraically using substitution. You can do elimination if you want to, but I'm going to use substitution here. So we can already see that y equals x plus 2 squared minus 9 and y equals 2x minus 6. Both equations are isolated for y, so it makes substitution very logical here. So what I'm going to do is I'm going to replace this y with x plus 2 squared minus 9. So the result is going to be x plus 2 squared minus 9 equals 2x minus 6. And now let's start to expand this, collect like terms, and see if we can solve for x. So let's see, x plus 2 squared. Well, x plus 2 squared is x plus 2 times x plus 2. If you FOIL that out, you get x squared plus 2x plus 2x plus 4, which is x squared plus 4x plus 4. Okay, so we get x squared plus 4x plus 4. That's coming just from the x plus 2 squared. Then we have minus 9. We want to get all the terms on the same side, so I'm going to take the 2x. I'm going to subtract it over here. So we're going to get a minus 2x. And then same deal. I'm going to take this negative 6 and add it over here. And we get plus 6 equals 0. So my goal here is to get one side equal to 0, which is what I did. Now let's collect all the terms together, collect like terms. X squared, let's see, 4x and negative 2x will give us plus 2x. And then 4 minus 9 plus 6, so 4 minus 9 is negative 5, negative 5 plus 6 is positive 1. So we get x squared plus 2x plus 1 equals 0. We need to go ahead and solve for this. I'm going to solve by factoring. Again, I think it's the most efficient method for a problem like this. So we need to think in terms of factors. What two numbers multiply to 1, but those same two numbers have to add to 2? Well, that's pretty easy. It's going to be 1 and 1, because 1 times 1 is 1, but 1 plus 1 is 2. And notice that because the factors are the same, well, if we set each of them equal to 0, you're going to get the same solution. So x plus 1 equals 0 tells us x equals negative 1. There is obviously no point to do this twice because you're just going to get negative 1 twice. So what this is telling us is that since there is only one possible x, when you plug it in, there's only going to be one possible y. Okay, one possible x means that there's only going to be one possible y. So let's go ahead and plug it in to find what that y value is going to be. So plug in x equals negative 1. Again, I'm going to plug it into the easier of the two equations, which is y equals 2x minus 6. So y equals 2x minus 6. Let's plug in x equals negative 1. This gives us y equals 2 times negative 1 minus 6, which is going to give us y equals negative 2 minus 6, which means y equals negative 8. And that's going to be our only solution. When x is negative 1, y is negative 8. So solution, negative 1, negative 8. So this is an example of a one-solution system, meaning that this linear equation, y equals 2x minus 6, when you graph it and you get the line, is only going to cross the parabola formed by this equation in exactly one spot. It will not cross in two different spots, just exactly one solution. So I'll put that right here, one solution. All right, so now let's see an example of a no solution system that contains both a quadratic and a linear equation. And this time I'm going to choose to solve it through elimination. You can do substitution if you want to. I'm just choosing elimination here. So for elimination, we want to line up and rearrange the equations. I want the y's to be the variable that gets eliminated because x is the squared variable. So I'm going to rearrange this as, for the top, negative 3y equals negative 2x plus 6. So I'm getting the y variable isolated on the left. The bottom equation we're going to leave alone. Y equals x squared plus x minus 1. Notice again I'm lining up the terms. The y terms are lined up. The equal signs, x squared, x's constants. And to get something to eliminate, well, I want to eliminate the y variables. So let's multiply the bottom equation by a positive 3. And the result that we're going to get, the resulting system, well, we're not multiplying the top, so the top is going to stay negative 3y equals negative 2x plus 6. The bottom equation, after multiplying all terms by 3, is going to be 3y equals 3x squared plus 3x minus 3. And now we can add the equations together. Negative 3y and 3y is going to be 0. 3x squared has nothing to add to, so it's just 3x squared. Negative 2x plus 3x is positive x. And 6 plus negative 3 is positive 3. And notice we now have an equation that we can solve for x, or we can at least attempt to solve for x. So that's what we're going to try now. We're going to solve 0 equals 3x squared plus x plus 3. Now, this one I'm going to try to solve using the quadratic formula. We've done factoring for all the other ones, and I think you're going to find out if you try factoring on this, it's not exactly going to work. So let's try to solve this one with the quadratic formula. The quadratic formula is negative b plus or minus, so actually x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. When I say a, b, and c, a is 3, b is 1, c is 3. Okay, so let's plug in those pieces. X equals, well, negative b, that's going to be negative 1, plus or minus the square root. B squared, that's going to be 1 squared, minus 4 times a is 3, times c is also 3. Everything divided by 2a, again, a is 3. All right, continuing to simplify. X equals negative 1 plus or minus the square root. And let's do some quick math here. 1 squared is 1. 4 times 3 times 3. So 3 times 3 is 9. 9 times 4 is 36. So this is 1 minus 36, which is negative 35. Then on the bottom, 2 times 3, that's going to be 6. Now, immediately, something should jump out to you here. You have a negative number under a square root, which means that you're not going to have any real solutions. So the negative 35 under the root means no real solution. Emphasis on real, no real solutions, meaning there are complex solutions, but we're not interested in complex solutions right now. So that means there are no real solutions. That looks bad. Let me do that again. There we go. So the negative 35 under the root means no real solutions. So that's a good example of a system of one linear equation, one quadratic equation that has no real solutions.